Question number 3. Two fishing boats start from a port. One travels 15 nautical miles per hour on a bearing of 25 degrees, and the other travels 18 nautical miles per hour on a bearing of 100 degrees. Assuming each maintains its course and speed, how far apart will the fishing boats be after 2 hours? So notice the one thing I said is I like to draw a picture. So before I started this video, I went ahead and sketched out a picture of what's going on just to organize our information a little bit so you didn't have to see me fumble through all this. So I've got our two fishing boats here, right? Here's the one that started out at 25 degrees and went in that direction. Here's the other one that went all the way to 100 degrees and went in that direction. Now, I took the fact that there's 2 hours involved. So if you travel 15 nautical miles per hour, after 2 hours, you've gone 30 nautical miles. So I put 30 m for the length of this distance. Now, if you travel 18 nautical miles an hour, after 2 hours, you've gone 36 miles. So I put 36 m for this. The question is, how far apart are these two boats? So here, I'm going to add a line tool, and I'm going to draw a line from where this boat is to where this boat is. And that's what we want to know. And since I'm talking about boats, I'm going to use the letter B for the distance of my boats. Now, if B is the distance of the boats from each other, then capital B is going to be my theta down here. And somebody's looking down here and they're saying, well, wait a minute now. You got 100 degrees for one boat and you got 25 degrees for the other boat. Where'd that 75 come from? And the idea is this. If this goes all the way over to 100 and this goes to 25, then this angle in the middle, we just subtract 25 from the 100 and we get 75. So the measure of this angle at this vertex is 75 degrees. So now, if you've been paying attention, hopefully you recognize that this is a side angle side relationship. And if I have side angle side, I'm going to be using the law of cosines. So B is what I want to know. So I'm going to go back in, grab my B squared, equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Now, in all honesty, the hard work's done. We've drawn a picture. We know what we're trying to find. So then we just do a little math. And the actual calculation's no big deal. We substitute. Copy everything here. And paste in our new information. So A, in this case, is either side. So I can let A be the 36 squared, which makes C the 30 squared, minus 2 times 36 times 30 times the cosine of 75 degrees. So as we substitute, 36 squared is 1296, 30 squared is 900, 36 times 30 is 1080, and now we can combine like. So we put in our simplified numbers so it's easier for us to type into the calculator. And now we want to get B. We're trying to find out the actual distance between these boats. So we want to take the square root. So B equals the 2196 minus 2160 cosine 75, all under the radical. So I'll just go to my graphing calculator and put this information in Desmos. So square root 2196 minus 2160 times the cosine of 75. And we get this number right here. So notice, I didn't round anything. So B is approximately 40.4592. So I could round to the nearest hundredth and say 40.46 nautical miles. And that's an example of how we can use the law of cosines to figure out something that I don't know if you could actually measure the distance between these. I mean, maybe a satellite could get kind of an idea using GPS of how far apart these are. But if we know enough information, we can definitely calculate that, even though we don't know a lot about where those two are in relation to each other. And that's number 3. So my expectation from you is your job to complete the problem of the week is that you guys do numbers 2 and